The Tupolev TB3 entered service with the VVS in 1932 as the world's first all-metal monoplane heavy bomber, a distinction that made it simultaneously an engineering achievement and a strategic anachronism by the time it saw serious combat. At 179 miles per hour maximum speed, it was slower than many fighters of its era, with fixed undercarriage and an open cockpit for the pilots. Yet it forced every other air force to reassess heavy bomber doctrine simply by existing at that scale. 818 were built, a figure no other nation matched in heavy bomber production until the United States entered the war. Andrei Tupolev designed the AN-T4 prototype in 1925. The production TB3 carried 5,291 pounds of bombs to a range of 1,864 miles, specifications that no other operational bomber in the world in 1932 could approach. The Soviet Union deployed TB3 units in mass formations during the 1939 Khalkhin Gol conflict against Japan and in the Winter War against Finland. Both operations revealed catastrophic vulnerability to fighter interception when attempted in daylight. By June 1941, the TB3 was doctrinally obsolete and operationally dangerous. Luftwaffe fighters destroyed entire formations in the opening days of Operation Barbarossa. The surviving aircraft were shifted to night operations, supply drops, and airborne assault support, roles where the aircraft's low speed was less immediately fatal. Despite its obsolescence, the TB3 continued flying combat missions until 1944. 818 of them had been built. The Soviet state consumed every one of them. The Tupolev SB-2 was the first Soviet aircraft that could legitimately claim operational equivalence with Western contemporaries at the moment of its introduction. At 263 miles per hour, the SB-2 was faster than most biplane fighters when it entered VVS service in 1936, earning it the designation high-speed bomber. This performance edge lasted approximately 3 years before monoplane fighter development closed it permanently. The SB-2 saw more combat in more conflicts than any other Soviet bomber of its era. Spanish Civil War operations beginning in October 1936 validated the high-speed concept against early biplane opposition. Chinese Nationalist Air Force SB-2s flew missions against Japanese forces through 1940. The type flew in the Winter War against Finland and in the border skirmishes at Khalkhin Gol. Each conflict degraded the performance advantage against more capable fighters, and by 1939 the SB-2 was being lost at rates the Soviet Air Force could sustain only because 6,967 had been built. Operation Barbarossa on June 22, 1941 destroyed SB-2 units in quantity. Flying in daylight formations against Bf 109 opposition, entire regiments were obliterated in hours. The problem was not the aircraft's age, it was the doctrine. Soviet bomber units flying in mass formation, unescorted, in daylight. That doctrine was purchased in blood before it was revised. The SB-2 was relegated to night operations by late 1941 and phased out of frontline service by 1944. Nearly 7,000 aircraft. The accounting was severe. The Ilyushin DB3 and its IL-4 derivative constituted the Soviet Union's primary long-range strategic bombing platform throughout the Great Patriotic War, the aircraft that carried the war to Berlin when no other Soviet machine could reach it. On the night of August 7th and 8th, 1941, a group of DB-3F aircraft from the 1st Mine Torpedo Aviation Regiment, Baltic Fleet, attacked Berlin. dropping bombs on the German capital in the same week Wehrmacht units were closing in on Leningrad. The Il-4 redesign of 1941 addressed the DB-3's most critical operational limitations without fundamentally altering the basic airframe. The 2,361-mile range was the aircraft's defining strategic asset. It could reach targets from Moscow that no other Soviet twin-engine bomber could approach. This range was achieved at significant cost to crew comfort and aircraft reliability, however. The Il-4 was notoriously difficult to fly and had one of the highest accident rates of any major Soviet aircraft type. 6,785 were built across all variants, serving from the first days of the war through 1944. The Il-4 flew torpedo attacks against German shipping in the Baltic, conducted partisan supply missions behind enemy lines, and bombed Berlin 4 times in 1941 alone. That operational breadth and the losses sustained achieving it defines the type as comprehensively as any specification table. The Petlyakov P-2 was the most produced Soviet bomber of World War II and, by the standards of its era, one of the finest light tactical bombers in any air force. At 360 miles per hour in its P-2FT variant, it was faster than many fighters it would encounter over the Eastern Front. Vladimir Petlyakov developed it from a high-altitude fighter design at the explicit directive of Stalin, who wanted a dive bomber equivalent to the Junkers Ju-88. Petlyakov worked on the design from a prison cell after his arrest in 1937. He was released upon the type's success and died in a P-2 accident in 1942. 11,427 P-2s were built, equipping the principal tactical bombing regiments of the VVS from 1941 through the end of the war. It flew against German armour at Kursk in July 1943, attacking panzer columns in coordinated strikes with Ilyushin Il-2 ground attack aircraft in operations that presaged Cold War NATO close air support doctrine. The aircraft's weaknesses were sustained. Its high wing loading made it demanding to fly. Its defensive armament was never fully adequate, and its range precluded deep strategic missions. It was a tactical weapon. Within that constraint, it was outstanding. 11,427 were built because the front consumed them and demanded more. The Petlyakov P-8 was the Soviet Union's only purpose-built 4-engine strategic heavy bomber of World War II, and the state built only 93 of them, a production figure that reflected both industrial priority decisions and serious technical problems that plagued the program from inception. Persistent engine unreliability, particularly with the AM-35A installation, delayed introduction and degraded operational effectiveness throughout the aircraft's service life. On the night of August 10th and 11th, 1941, P-8 Ace made the first of several raids against Berlin, a feat of political symbolism that, given 93 aircraft existed, and not all were operational, required careful allocation of scarce resources against targets of questionable military value. The raids damaged Berlin minimally, but proved that the Soviet Union retained a strategic bombing capability that German propaganda had claimed was destroyed. Foreign Minister Molotov flew to London in a P-8 in May 1942, a round-trip journey of political importance conducted in the only 4-engine Soviet aircraft that could manage the distance. The P-8's most significant documented contribution was the delivery of the first Soviet 5,000-kilogram Fabi 5000 bomb against German positions near Kharkov in 1943. 93 aircraft could not constitute a strategic bombing campaign. They constituted a capability demonstration. The Tupolev Tu-4 was built from 3 American B-29 superfortresses that made emergency landings in Soviet territory in 1944, aircraft that Stalin ordered, copied with exact fidelity, down to the ashtrays and the crew's candy wrappers. Tupolev's team reverse-engineered every rivet, every weld, every piece of avionics within 2 years. The result was functionally identical to the B-29, updated with Soviet systems, and was operational in 1947, 3 years before the United States knew the Soviet Union possessed this capability. When the Tu-4 flew over Moscow on August 3, 1947 in the annual Aviation Day parade, Western intelligence had only a photograph and a strategic crisis. 847 Tu-4s were built, equipping the Long-Range Aviation Command's regiments by 1950. Their range of 3,600 miles gave them a one-way capability against targets in Alaska, Greenland, and potentially the US East Coast. The Tu-4 was also the delivery platform for the first Soviet atomic weapon carried in an aircraft, tested on October 18, 1951. The Tu-4's limitations were equally significant: no jet propulsion, no in-flight refueling capability, and crews who understood they were flying one-way missions against an adversary with functional air defenses. Its successor, the Tu-16 and Tu-95, arrived before the Tu-4 was fully operationally deployed. The aircraft that created the Soviet strategic bomber force was replaced almost as soon as it achieved operational maturity. The Ilyushin Il-28 was the Soviet Union's first jet bomber, entering service in 1950 with engines derived directly from the Rolls-Royce Nene that Britain had sold the Soviets in 1946. 6,316 were built for Soviet service. Thousands more were exported to China, Egypt, North Korea, and Warsaw Pact nations. It became the most numerically significant jet bomber in history. The Il-28's design philosophy prioritized ease of production and maintenance over technical sophistication. At 559 miles per hour, it was adequately fast for its era, but not exceptional. Its tactical nuclear certification in 1955 gave it a second operational dimension, a conventional tactical bomber that could be configured for nuclear delivery without structural modification. The Il-28 achieved its most prominent political moment in October 1962, when Soviet personnel in Cuba were observed assembling Il-28 bombers at San Julian Air Base, aircraft whose range could reach Miami from the island. President Kennedy demanded their removal as part of the Cuban Missile Crisis resolution. Khrushchev complied. The Il-28s crated back to the USSR never fired a weapon. Their delivery to Cuba had nonetheless been sufficient to constitute a strategic threat. The Tupolev Tu-16 gave the Soviet Union its first genuine jet-powered long-range strategic bombing capability, a swept-wing twin jet that combined the range to reach targets in Western Europe and the Middle East with a cruise speed that made interception difficult for the fighters of the early 1950s. Its 4,598-mile range could cover any target in Western Europe from Soviet bases east of the Urals, eliminating the vulnerability of frontline basing. 1,509 were built, equipping long-range aviation and naval aviation in parallel. The Tu-16's most significant strategic contribution was not the original bomber variant, but the derivatives, the Tu-16K-10 carrying the AS, two-kipper anti-ship missile, the Tu-16K-26, equipped with the AS-6 Kingfish, and the Tu-16A, configured as a nuclear delivery platform. Soviet naval aviation Tu-16K variants threatened American carrier battle groups from the late 1950s through the 1980s. China received 98 Tu-16s in 1959, designating them the H-6, which remains in Chinese service in 2024 in heavily modified forms, a direct lineage from a 1950s Soviet airframe to 21st century PLA bomber operations against Taiwan scenarios. The Tu-16's airframe outlasted not just the Soviet Union, but most of the aircraft designed to replace it. The Mi-24 M4. Bison triggered the American B-52 program's acceleration and then disappointed the Soviets who built it. When the M4 flew over Moscow on May 1, 1954, American intelligence officers watching from the Red Square balcony counted what appeared to be a large force of swept-wing intercontinental jet bombers. The bomber gap of 1955 to 1957, subsequently revealed as largely illusory, drove emergency B-52 production schedules. The Soviets had achieved strategic deterrent effect through a parade maneuver before the aircraft was operational. Vladimir Myasishchev's design bureau produced a technically ambitious aircraft that fell short of its intercontinental requirement without in-flight refueling. Only 93 were built before Myasishchev's bureau was dissolved in 1960, with production and strategic requirements transferred to Tupolev. The surviving M4S served as aerial tankers for the Tu-95 and later as the 3MS Strategic Reconnaissance Platform, roles imposed by operational inadequacy in the primary mission. The aircraft that created the bomber gap in American strategic planning was never capable of executing the mission that gap assumed it could perform. The Tupolev Tu-95 Bear has been in continuous frontline service longer than any other combat aircraft in history, first flying in 1952, entering service in 1956, and still conducting maritime reconnaissance and cruise missile strike missions for Russia in 2024. Its longevity derives from a design choice that appeared retrograde in 1952, turboprop engines rather than turbojets, giving range that no jet bomber of the period could match. The NK-12M engines, each generating 15,000 shaft horsepower, drove contra-rotating propellers that produced a distinctive sound, detectable at 50 miles on passive sonar. At 9,400-mile range without refueling, the Tu-95 was the first Soviet aircraft that could conduct a round-trip bombing mission against the continental United States from Soviet territory, without dependency on one-way sacrifice profiles. It also could carry the Soviet Union's largest thermonuclear devices, including the Tsar bomber, the AN-602 device tested on October 30, 1961, which yielded 50 megatons, and whose delivery aircraft survived the detonation by flying away at maximum speed, still being thrown violently by the shockwave at 100 miles distance. Tu-95 MS aircraft launched Kh-101 cruise missiles against Ukrainian targets in 2022 and 2023. Operating from Russian airfields well inside Russian territory. An aircraft designed in 1951, conducting combat operations in 2023, represents a continuity of service without parallel in aviation history. The Tupolev Tu-22 Blinder was the Soviet Union's first supersonic bomber and one of its most difficult aircraft to operate, generating an accident rate and aircrew attrition that long-range aviation commanders found unacceptable for most of the type's operational life. The engine placement, 2 turbojets mounted at the tail base on either side of the vertical stabilizer, drove maintenance man-hours to levels that degraded operational readiness below acceptable thresholds in the early service years. Soviet maintenance crews and crews nicknamed it the Funeral, a reference to the difficulty of both flying it and keeping it airworthy. Mach 1.42 at altitude was the Tu-22's primary justification. An aircraft penetrating NATO airspace at supersonic speed significantly complicated the interceptor problem. The window of advantage narrowed as Western SAM development caught up with supersonic penetration profiles, and the Tu-22 gradually transitioned to a standoff role using the Kh-22 kitchen missile. Libya's Tu-22s flew combat missions in Chad during the 1986 and 1987 conflict. Iraq operated Tu-22s extensively in the Iran-Iraq War, striking Iranian cities. The type's operational record outside the Soviet Union was modest. 313 were built. The accident rate consumed enough of them that operational strength was never as large as the production figure implied. The Yakovlev Yak-3 Brewer was Soviet frontal aviation's primary supersonic tactical nuclear bomber through the 1960s and 1970s, equipping the tactical air armies opposite NATO's Central European Front with a nuclear delivery capability that Allied air defense planners specifically had to account for in their war planning scenarios. At Mach 1.13, the Yak-28. I could not penetrate the most sophisticated Western air defenses in the mid-1970s without significant attrition, but in the early 1960s against the air defense networks of the period it represented a genuine and specific threat. 1,180 Yak-28s were built across several variants: the Yak-28 Brewer bomber, the Yak-28P Firebar interceptor, and the Yak-28R reconnaissance variant, the Yak-28. I was specifically certified for the delivery of the RN-28 tactical nuclear weapon, giving Soviet frontal aviation commanders an organic nuclear option that did not depend on long-range aviation or the strategic missile forces. An incident in April of 1966 brought the Yak-28 to unusual prominence. A Yak-28 crashed into the Havel River in West Berlin, creating a Cold War diplomatic incident as British and Soviet forces both attempted to recover the wreckage and its classified equipment. The aircraft was eventually recovered by British forces. The electronic systems were returned to the Soviets after examination. That examination provided Western intelligence with detailed knowledge of Soviet avionics that influenced NATO electronic warfare development for years afterward. The Tupolev Tu-22M backfire became the central argument in the SALT II treaty negotiations of 1979, with the Soviet Union insisting it was not a strategic intercontinental bomber, and with US negotiators accepting that position because the alternative was a strategic impasse that would have ended the treaty. The Tu-22M3 could reach the US continental mainland with aerial refueling. Soviet negotiators agreed to remove in-flight refueling probes from the aircraft as a treaty confidence measure. The probes were reattached to several aircraft within months. At Mach 2.05, with a 4,350-mile combat radius and carrying the Kh-22 kitchen anti-ship missile, a weapon capable of Mach 3.5 and a 1,000-kilogram warhead, the Tu-22M3 posed a specific threat to American carrier battle groups. Two Tu-22M3 aircraft could theoretically saturate the air defense of a carrier group with Kh-22 salvos. The specific scenario drove development of the F-14 Tomcat's AIM-54 Phoenix missile as a direct counter to 22 M3's conducted combat operations in Afghanistan from 1988. Russian Tu-22 M3s flew extensive strike missions in the 2008 Georgia War and have operated against Syria since 2015. In 2024, Ukrainian forces have destroyed Tu-22 M3s at Russian air bases, the first losses of this airframe in combat since its introduction. The Tupolev Tu-160 Blackjack is the heaviest combat aircraft ever built. A supersonic variable geometry bomber whose 88,185-pound payload capacity exceeds the B-52H's maximum load by 18,000 pounds and whose maximum gross takeoff weight of 606,260 pounds makes it the largest warplane to have entered serial production. The four NK-32 afterburning turbofans each produce 55,115 pounds of thrust, giving a combined power output of 220,000 pounds, more than any other aircraft in history. Tu-160s entered service with the 184th Heavy Bomber Regiment at Pryluki, Ukraine, in 1987. When the Soviet Union dissolved in 1991, 19 of the 36 completed aircraft were at Ukrainian bases. Ukrainian nationalists physically destroyed 6 with sledgehammers under US oversight as part of Nunluga denuclearization, an act that eliminated 1/4 of the global Tu-160 fleet with farm equipment. Tu-160s launched Kh-101 cruise missiles against Ukrainian targets beginning in 2022, their first use of standoff weapons in combat. Russia resumed Tu-160 production in 2022, announcing the Tu-160M2 upgrade program. The aircraft that the Soviet Union built as its ultimate strategic deterrent outlasted the state that built it by more than 30 years. The Sukhoi Su-24 Fencer was Soviet frontal aviation's answer to the American F-111, a supersonic, variable geometry, all-weather interdiction aircraft designed to penetrate NATO air defenses at low altitude and high speed, delivering conventional or nuclear weapons against airfields, logistics nodes, and command centers in the critical first 72 hours of a European war. The Su-24M upgrade incorporated a terrain-following radar and the Kyra-24 laser designator, making it the first Soviet aircraft capable of precision-guided munitions delivery with reliability comparable to Western systems of the period. More than 1,400 Su-24s were built, equipping dozens of regiments across the Soviet Union and Warsaw Pact. Soviet Air Force pilots considered the Su-24's low-level handling at supersonic speed among the most demanding of any aircraft in the inventory. The workload of terrain following at 200 feet and 600 knots in a variable geometry aircraft-taxed cruise beyond the capacity of routine training. Su-24Ms flew in Afghanistan, both Gulf Wars in Iraqi service, the Georgia War of 2008, and extensively in Syria from 2015. Ukrainian Su-24Ms delivered British Storm Shadow cruise missiles against targets deep inside Russian-occupied territory from 2023, the first time an Su-24 variant delivered Western precision-guided munitions in combat. The aircraft, designed to strike NATO, is now carrying NATO weapons. The Tupolev Tu-95 MS Bear H is a distinct aircraft from the earlier Tu-95 bomber variants, not an upgrade, but a new production variant built on the same airframe to serve as a dedicated cruise missile carrier. 88 were built between 1979 and 1992, equipped with the rotating launch drum for the KH-55 subsonic cruise missile in the weapons bay. The KH-55 had a range of 2,500 kilometers and carried a 200-kiloton warhead, giving the Tu-95MS a standoff nuclear strike capability that negated the aircraft's vulnerability to increasingly sophisticated Western air defenses by keeping it hundreds of miles from the targets it was assigned to destroy. The transition from penetrating bomber to standoff launch platform reflected a broader Soviet strategic shift in the late 1970s. The recognition that improvements in Western SAM systems had made the airspace over Western Europe genuinely hostile to conventional penetrating attack profiles. Tu-95MS aircraft could launch from positions over the Barents Sea against targets in Western Europe without entering defended airspace. Russia upgraded surviving Tu-95MS airframes to carry the KH-101 conventional cruise missile and has used them extensively against Ukraine since February 2022. Launch sequences have involved Tu-95MS formations operating from Engels Air Base near Saratov, with cruise missile salvos timed to saturate Ukrainian air defense alert cycles. The Bear H's operational relevance in 2024 demonstrates the strategic durability of the standoff missile platform concept first validated in 1983. The Mi-24 M52 and M56 were the Soviet Union's most ambitious unrealized bomber programs. Aircraft designed for intercontinental range at Mach 3 that would have directly competed with the American B-70 Valkyrie in the high-altitude, supersonic penetration role. Vladimir Myasishchov's design bureau had developed multiple configurations through the late 1950s, progressing from the M50 prototype, which flew in 1959, toward the M52 and M56 designs that would carry greater fuel and weapons loads to intercontinental ranges at sustained Mach 3 cruise speeds. Nikita Khrushchev terminated Myasishchov's design bureau in 1960 and dissolved the M50 program along with it, redirecting the resources to intercontinental ballistic missile development. The decision reflected Khrushchev's personal conviction that missiles had made manned bombers obsolete, a position that the subsequent history of Soviet and Russian bomber development proved incorrect, but which was plausible given the technology of 1960. The M50 that flew in 1959 was displayed at the 1961 Tushino Air Show, Western observers misidentifying it as operational. It was a prototype of a program already dead. The Americans cancelled their equivalent, the B-70, the same year Khrushchev terminated the Soviet program, reaching the same conclusion from opposite directions. The Sukhoi T-4, called Sotka in reference to its 100-ton design weight, achieved Mach 3 in the prototype stage before the Soviet government cancelled it in favour of the Tu-22M backfire, ending the most technically ambitious Soviet bomber program that actually flew. The single T-4 prototype conducted 10 flights between 1972 and 1974, reaching Mach 1.36 on its own engines and demonstrating the structural integrity of a titanium-dominant airframe designed to sustain kinetic heating at sustained Mach 3 cruise. Pavel Sukhoi's design bureau had never built a large bomber before the T-4. The project consumed a decade of development effort and pushed Soviet metallurgy, avionics, and propulsion to their contemporary limits. The RD-3641 engines each produced 35,270 pounds of thrust, purpose-designed for the application, and the fly-by-wire flight control system was the first to be fitted to a Soviet aircraft of this size. The decision to cancel the T-4 in favour of the less technically demanding Tu-22M reflected not technical failure, but political economy. The Tupolev Bureau had superior institutional relationships with the Defense Ministry, and completing 2 new strategic bomber programs simultaneously was a resource allocation that the Soviet defense budget would not support. The T-4 prototype sits in the Menino Air Force Museum. Mach-3 and cancelled. Soviet aerospace produced both regularly. April 24, 1946. The dawn of the Soviet jet age arrived in a frantic, synchronized roar. On that single day, the Mikoyan Gurevich MiG-9 took to the skies, narrowly beating its rival, the Yakovlev Yak-3, to become the Soviet Union's first operational jet fighter. Commissioned into the Soviet Air Forces in 1947, with 610 units eventually rolling off production lines, this crude pioneer was less of a tactical triumph and more of an institutional crucible. Engineers struggled to integrate heavy cannon armaments with volatile early jet turbine technology. The result was a catastrophic design flaw. Firing the nose guns at high altitudes generated a suffocating muzzle blast that starved the primitive engines of oxygen, instantly extinguishing them in mid-flight. For much of its frontline service life, pilots operated under strict operational restrictions that effectively crippled their firepower. Exported to China in 1950 to bolster a nascent communist air arm, the MiG-9 served its purpose not as a dominant weapon of war, but as an essential, dangerous stepping stone. It taught the Soviet aviation industry how to build, maintain, and fly jets, even if its main weapons remained terrifyingly unreliable. First taking flight on June 17, 1947, and entering official VVS service by 1948, the Yakovlev Yak-3 was destined to be the final straight-wing jet fighter designed by the legendary Yakovlev Bureau. Its creation was catalyzed by an unexpected geopolitical windfall, the British Attlee government's controversial 1946 decision to sell advanced Rolls-Royce, Nene and Derwent turbojet engines directly to Moscow. Soviet engineers reverse-engineered the Derwent to produce the RD-500 power plant. This gave the lightweight Yak-3 an astonishing low-altitude performance advantage that completely outclassed the primitive BMW-derived engines powering the rival MiG-9. Recognizing its utility, Moscow transformed the Yak-3 into a political and intelligence tool. The fighter was widely exported across Eastern Europe, providing Romania, Poland, Bulgaria, and Czechoslovakia with their very first jet-propelled air forces. Yet, this export program was far more than a simple security assistance package. It operated as a sophisticated intelligence harvesting operation. Soviet military advisors accompanied every single aircraft shipment, meticulously gathering crucial doctrinal and operational performance data. This field intelligence directly shaped Soviet strategic planning for the looming confrontation with NATO. On December 30th, 1947, an aviation legend was born. The Mikoyan Gurevich MiG-15 first took flight, entering Soviet service in 1949, before bursting onto the global stage over Korea in November 1950. It instantly shattered Western complacency, rendering every straight-wing American aircraft in theater completely obsolete overnight. This aerodynamic masterpiece combined 2 distinct technologies: a reverse-engineered British Rolls-Royce Nene turbojet engine acquired through the Attlee government, and a radical 35-degree swept wing developed from captured German wartime research. The threat was immediate and lethal. Initial Soviet squadrons over Korea were flown by elite VVS pilots wearing Chinese uniforms under strict orders to avoid capture at all costs. By December 1950, American commanders were forced to suspend all daylight B-29 bombing missions over North Korea. The MiG-15 was simply destroying the massive bombers faster than American escort fighters could defend them. Production numbers exploded to a staggering 17,508 aircraft manufactured across the Soviet Union, Poland, and Czechoslovakia. It became the first Soviet fighter widely exported on a global scale, serving 40 nations. The Mikoyan Gurevich MiG-17 first took to the skies on January 14, 1950, entering frontline service in 1952. While 10,649 units were eventually built, this transonic fighter achieved its ultimate historical notoriety a decade later in the humid skies over North Vietnam. In 1965, the aircraft became the ultimate asymmetric threat. Armed only with heavy, hard-hitting conventional cannons, the subsonic MiG-17 routinely downed sophisticated American supersonic aircraft in brutal, close-range dogfights. It was an arena for which American pilots, trained exclusively for high-tech, long-range missile warfare, were completely unequipped and unprepared. The older, slower Soviet fighter consistently defeated platforms that were a full generation more advanced, simply because the restrictive, visual rules of engagement in Vietnam perfectly favored the older weapon's tight turning radius. American fighter crews flying the massive Mach 2.23 Republic F-105 Thunder Chief found themselves trapped in turning dogfights where their speed advantages were useless and their early air-to-air missiles failed to lock. The MiG-17 proved that high technology is meaningless if the enemy forces you to fight on their own terms. On January 5, 1954, Soviet aviation shattered the sound barrier. The Mikoyan Gurevich MiG-19 took its maiden flight, entering official service in 1955 as the Soviet Union's very first production supersonic fighter. Capable of reaching Mach 1.35 at high altitude, it was the first Soviet aircraft engineered to break the sound barrier in stable, level flight and sustain those extreme speeds under standard operational conditions. While its frontline service within the Soviet Air Forces was relatively brief due to rapid technological advancements, its international legacy was monumental. Moscow transferred the MiG-19 design technology to Beijing, where it was manufactured as the Shenyang J-6. Chinese factories built over 3,000 of these rugged fighters, turning the platform into a cornerstone of Asian air power. Pakistani J-6 crews flew the type into intense combat against India during the border wars of 1965 and 1971, proving its lethal agility in skilled hands. Chinese variants remained in active service well into the 1990s. Though frequently overshadowed by its successor, the MiG-19's massive Chinese production run guaranteed its global impact. First flying on February 14, 1956, and entering service in 1959, the Mikoyan Gurevich MiG-21 became the definitive symbol of Soviet military aviation philosophy. Mass-produced in 13 major variants through 1985, a mind-boggling 11,496 aircraft were built across 4 nations. Deployed by 56 countries, It stands as the most widely produced supersonic fighter in human history. The fishbed was engineered to be small, lightning fast, cheap to manufacture and remarkably easy to maintain, a mass-produced defensive interceptor optimized for short-range combat. Its legendary 50-year global combat record reveals a flickered, consistent pattern. It was absolutely lethal in close-range turning dogfights, especially when guided by well-trained pilots. However, it remained highly vulnerable to beyond visual range missile attacks due to its severely limited onboard radar. When matched against superior Western avionics and highly trained adversaries, it was routinely outclassed. Yet, its longevity is unmatched. The Indian Air Force proudly operated its upgraded MiG-21 fleet all the way through 2025. This iconic Delta Wing warrior ultimately outlasted the superpower that created it. Entering service with the Soviet Air Defense Forces in 1959, the Sukhoi Su-9, alongside its later upgraded variant, the Su-11, was built for a singular, terrifying strategic purpose. These all-weather interceptors occupied a highly specific niche within the Cold War chessboard. They were pure, unadulterated rocket ships optimized solely to scramble, climb to extreme altitudes at blistering speeds, and destroy incoming Western strategic nuclear bombers. They sacrificed maneuverability, range, and landing safety to achieve unmatched altitude performance. This desperate design philosophy was laid bare on May 1st, 1960. When Francis Gary Powers' American U-2 spy plane penetrated Soviet airspace, pilot Igor Mentyukov was scrambled in an unarmed Su-9. His direct, suicidal orders from high command were simple: ram the American aircraft at 70,000 feet. Mentyukov successfully clawed his way up to the U-2's extreme operational altitude, but ran out of fuel before he could close the distance to execute the collision. An SA-2 surface-to-air missile claimed the historic kill instead. Both the Su-9 and Su-11 remained shrouded in secrecy until phased out after 1965. Entering service in 1965 with 1,290 units constructed, the twin-engine Mach 2.5 capable Sukhoi Su-15 served as the steel backbone of Soviet homeland air defense throughout the 1970s and early 1980s. It was a ruthless, no-nonsense interceptor built to guard the expansive, forbidden borders of the USSR. However, its historical legacy was forever defined by a single, tragic international incident. On September 1st, 1983, a Soviet Su-15 piloted by Gennady Osipovich intercepted Korean Airlines Flight 007, a commercial Boeing 747 civilian airliner that had drifted off course into sensitive Soviet airspace near Sakhalin Island. Operating under strict military protocols, Osipovich fired 2 heavy air-to-air missiles. Both struck the airliner, causing it to break apart and plunge into the sea, killing all 269 civilian passengers and crew aboard. The global outrage was immediate and profound. This horrific Cold War tragedy generated immense political pressure that directly accelerated the United States military's deployment of the Global Positioning Satellite System for civilian aviation. The modern GPS navigation network was fast-tracked to prevent future violations. First, flying on June 10, 1967 and entering frontline service in 1970, the Mikoyan Gurevich MiG-23 was a radical departure from its predecessors. With 5,047 units constructed across 9 distinct variants through 1985, this complex fighter introduced variable sweep-wing geometry to the Soviet arsenal. The Flogger was engineered to provide tactical aviation squadrons with blistering speed and, for the first time, a genuine beyond visual range missile engagement capability. Moscow aggressively exported the MiG-23 to 25 Allied nations, ensuring it fought in more global hotspots than almost any other Soviet combat aircraft of its generation. Its combat resume spans the battlefields of Angola, Libya, Syria, Iraq, Afghanistan, and North Korea. Yet its sophisticated technology rarely translated into clear operational dominance. In the skies over the Middle East, highly trained Israeli fighter pilots flying advanced American aircraft routinely outmaneuvered and destroyed export MiG-23s. Despite the Soviet jet's undeniable raw speed, powerful radar, and swing-wing adaptability, it was repeatedly defeated by superior Western tactical training and electronic countermeasures. The Mikoyan Gurevich MiG-25 first tore into the sky on March 6, 1964, entering air defense service in 1970. 1,186 of these titanium-scarce monsters were built. The Foxbat was originally engineered for a single mission, to intercept the American Mach 3 XB-70 Valkyrie bomber. But when Washington abruptly cancelled the Valkyrie project, the Kremlin was left with a terrifying Mach 3 interceptor that possessed no equivalent target to hunt. For a decade, Western intelligence feared it as an invincible, high-tech superfighter. That illusion shattered completely in 1976 when pilot Viktor Belenko defected, landing his MiG-25 in Japan. Western engineers disassembled the jet and discovered a ruthlessly primitive masterpiece. It was constructed not of exotic titanium, but 80% nickel-steel alloy. Its electronic brains relied on outdated vacuum tubes rather than microchips, and its massive radar generated a blistering 600 kilowatts of power simply to blast through Western jamming via brute force. While interceptor variants guarded the homeland, specialized reconnaissance models flew over Israeli positions with total impunity for years. First flying on November 20th, 1972, and entering service in 1975, the Mikoyan Gurevich MiG-27 represented a powerful realization by Soviet commanders. The sleek, swing-wing MiG-23 airframe could be modified into a devastating mud mover. Designers completely flattened the aircraft's nose, removing the heavy air intercept radar to install an advanced laser, rangefinder, and target acquisition system. Beneath the cockpit, they packed a monstrous 30mm Geesh 630 rotary cannon capable of spitting 6,000 rounds per minute, a weapon so violent its recoil frequently shattered landing lights and cracked instrument panels. This specialized ground attack platform found its greatest international home in India. The Indian Air Force acquired the type and manufactured it under license as the Bahadur, or Valiant. Incredibly, India kept these vintage strike fighters operational through 2021, an astonishing 46 years after the design's maiden flight. However, this long-term operational relationship was deeply troubled. India's aviation history was marred by numerous fatal crashes and accidents directly attributed to persistent, volatile engine reliability issues that Soviet designers had never fully resolved. The Mikoyan Gurevich MiG-31 took flight on September 16, 1975, and entered frontline service in 1981, bringing an unprecedented level of electronic warfare to the Cold War. It was equipped with the revolutionary Zaslon weapon system, the world's very first phased-array radar ever fitted to a production fighter aircraft. This advanced sensor allowed the Foxhound to track 10 separate targets simultaneously and engage 4 of them at extreme ranges with long-range missiles, a terrifying cooperative engagement capability that Western air forces would fail to replicate for over a decade. Built to replace the aging MiG-25, this heavy twin-engine interceptor proved to have an astonishingly resilient design. The MiG-31 remains in active Russian combat service today, comfortably outlasting the Soviet Union by more than 3 decades. In a stunning historical twist, this vintage Cold War interceptor has been heavily modernized and repurposed. Since 2022, modified MiG-31 units have served as the primary airborne launch platforms for the Kinzhal hypersonic aeroballistic missile during intensive combat operations over Ukraine. Entering service with Soviet naval aviation in 1976 to fly from the decks of the new Kiev-class aviation cruisers, the Yakovlev Yak-3 was Moscow's ambitious, troubled entry into the world of vertical takeoff aviation. 231 of these unique aircraft were built, but the forger was plagued by severe fundamental engineering limitations. In tropical climates or hot weather conditions, the lift engines lost massive amounts of thrust, rendering the aircraft completely incapable of carrying a useful weapons payload or fuel load while executing vertical operations. Even more terrifying for its pilots was the aircraft's highly volatile automatic ejection system. Designed to save the pilot during a sudden lift engine failure, the computer system could trigger the ejection seat entirely on its own without any human input. Pilots routinely joked that the Yak-3 was the only aircraft that could decide, entirely independently, to throw its pilot out of the cockpit. The problematic type was swiftly withdrawn from service by 1992, but its vertical flight engineering data was ultimately purchased by Lockheed Martin for the F-35B program. The Mikoyan-Gurevich MiG-29 first took to the sky on October 6, 1977, entering service in 1983 as a premier agile dogfighter. Engineered specifically to challenge American air superiority, the Fulcrum shook Western intelligence to its core by introducing a revolutionary close combat system. The combination of the highly maneuverable R-73 infrared missile and the Shell-3 helmet-mounted targeting sight. This allowed Soviet pilots to lock onto and destroy an enemy aircraft simply by looking at it, up to 45 degrees off the nose. Following the historic fall of the Berlin Wall and German reunification, the Western Alliance inherited an active fleet of East German MiG-29s into the Luftwaffe. Mock dogfights shocked NATO commanders. In close-range aerial combat, the MiG-29 was virtually unbeatable, outclassing every Western fighter of the era. However, outside of a close-in knife fight, the aircraft suffered major weaknesses. Its primitive onboard radar, cramped cockpit ergonomics, and outdated analog avionics were a full generation behind its American counterparts, making beyond visual range survival incredibly difficult. First taking flight on August 2, 1966, and entering service in 1970, the Sukhoi Su-17, along with its export derivatives the Su-20 and Su-22, was Moscow's ultimate solution to a complex tactical problem. Soviet commanders needed a heavy fighter bomber capable of high-speed supersonic dash speeds at altitude while simultaneously maintaining stable, safe handling characteristics during low-level bombing runs. Their answer was a robust, swing-wing design that resulted in 2,867 aircraft being built. During the grueling Soviet-Afghan War from 1979 to 1989, these rugged fitters served as the primary workhorse for tactical ground strikes. However, the introduction of American-supplied Stinger Man portable missiles with their deadly 3.5-kilometer engagement ceiling forced Su-17 pilots to abandon low-level attacks. They adopted high-altitude bombing profiles that severely compromised weapon accuracy but ensured aircraft survivability. The type also made global headlines on August 19, 1981, over the Mediterranean Sea, when two Libyan export Su-22s actively challenged United States Navy F-14 Tomcats over the disputed Gulf of Sidra and was swiftly shot down. The Sukhoi Su-24 made its maiden flight on January 17, 1970, and entered active service in 1974. With over 1,400 units rolling off production lines, this heavy, variable sweep-wing aircraft was the Soviet Union's direct strategic answer to the American General Dynamics F-111 Aardvark. The Fencer represented a massive technological leap for Moscow, debuting as the first Soviet combat aircraft equipped with an integrated terrain-following radar and navigation system, giving it a genuine all-weather, day or night precision strike capability. It was built to fly fast and low, slipping underneath Western radar nets to deliver conventional or nuclear payloads deep inside NATO territory. Decades later, however, it fell victim to the very alliance it was designed to destroy. On November 24, 2015, a Turkish Air Force F-16 shot down a Russian Air Force Su-24M along the highly volatile Syrian-Turkish border. It marked the first time a NATO country had destroyed a Russian military aircraft since the Korean War, a conflict its long-dead designers never envisioned. First flying on May 20, 1977 and entering frontline service in 1985, the Sukhoi Su-27 was engineered to be the ultimate predator of the skies, built in direct response to the American McDonnell Douglas F-15 Eagle. It featured a massive airframe with an extraordinary unfueled operational range of 3,530 kilometers. The world stood still at the 1989 Paris Air Show when chief test pilot Viktor Pugachev shocked Western observers by performing a radical maneuver known as Pugachev's Cobra. He pitched the heavy fighter up to a staggering 120 degrees angle of attack, forcing the nose to point momentarily backward before recovering smoothly into level flight. No Western fighter could replicate it. The maneuver proved the Su-27 could aerodynamically decelerate faster than any pursuing aircraft, instantly turning a tail chase into a lethal head-on missile engagement on the Sukhoi's own terms. The incredibly versatile flanker airframe became the foundational architecture for an entire dynasty of modern combat aircraft across 20 nations. In the wake of World War II, the Soviet Union faced a glaring tactical gap in the skies. They lacked a viable helicopter. Enter Mikhail Mil. On September 20, 1948, a fragile insect-like aircraft lifted off into aviation history. This was the Mil-Me-1, codenamed Hare by NATO. Entering full Soviet military service in 1950, this pioneering machine would see a production run of approximately 1,000 units. To conquer the engineering challenges of vertical flight, Mil engineered a three-blade semi-rigid main rotor paired with a single roaring piston engine. His design, ingeniously fused, captured German wartime research with emerging American Sikorsky principles simultaneously. Yet, the true value of the Hare was not found in frontline combat doctrine. Instead, its triumph was entirely institutional. The Mi-1 proved beyond doubt that the Mill Bureau could successfully manufacture a reliable helicopter at scale. This vital stepping stone established the massive industrial infrastructure, production lines, and engineering expertise required to birth future giants like the Mi-4, Mi-6, and the legendary Mi-8. Poland actively manufactured its own licensed SM-1 and SM-2 variants all the way through 1965. It was a humble beginning for a superpower's rotary revolution. In the early 1950s, Cold War tensions reached a boiling point on the Korean peninsula. High-ranking Soviet officials watched with growing alarm as American Sikorsky H-19 helicopters revolutionized battlefield mobility. Recognizing the strategic threat, Joseph Stalin personally intervened, issuing an absolute, uncompromising dictate: the Soviet Union must build an equivalent counterpart within one single year. Rising to this impossible challenge, Mikhail Mill worked around the clock, delivering a flying prototype in just 13 months. First taking flight on May 3, 1952, the Mill Mi-4, known to Western intelligence as the Hound, entered active military service in 1953. It became the ultimate proof of concept for Soviet rotary warfare, with over 3,500 units built. The Hound was a rugged workhorse, capable of accommodating 11 fully equipped combat troops, 1,600 kilograms of internal cargo, or even a formidable 76mm field gun loaded through its innovative rear clamshell doors. This versatile platform provided the Red Army with an unprecedented level of tactical flexibility. Its global impact extended far beyond Soviet borders, as China eagerly manufactured its own licensed copies, designated the Z5, all the way through 1979. The Hound had successfully cemented the Soviet Union's status as a true global pioneer in military helicopter deployment. June 5, 1957. The Soviet Union unveils an aviation marvel that completely shatters the limits of vertical lift. The Mill Mi-6, codenamed Hook, took to the skies, entering service in 1959. This colossal machine was a double threat. It reigned simultaneously as the largest and the fastest helicopter on Earth, setting a staggering speed record of 320 kilometers per hour in 1965. Western analysts watched in disbelief. The Hook represented a massive leap in scale that nothing in the Western arsenal could match until the Sikorsky CH-54 Tahe arrived a decade later. Boasting a massive 12-ton internal payload capability, the Mi-6 could single-handedly transport heavy 122mm howitzers, armored personnel carriers, and complex engineering equipment sets in a single lift. Over its lifespan, 926 airframes were built, but its most harrowing hour arrived in April 1986. Following the catastrophic nuclear meltdown at Chernobyl, fleets of Mi-6 and Mi-8 helicopters flew 1,800 desperate sorties, dropping 5,000 tons of shielding material directly into the burning reactor core under deadly radiation conditions with no operational precedent. These legendary mechanical titans were finally retired in 2002, closing an extraordinary chapter in aviation history. Their sacrifice preserved countless lives and showcased the sheer brute force of Soviet engineering. While the Mill Design Bureau focused on raw power and conventional configurations, another visionary engineer was forging a radically different path. Nikolai Kamov championed the complex world of coaxial counter-rotating rotors. The manifestation of this unique philosophy was the Kamov Ka-18, designated by NATO as the Hog. First flying in 1956 and entering official service in 1957, this compact, intriguing aircraft saw a modest production run of approximately 100 units, but the true impact of the Ka-18 was not measured in massive fleet numbers or frontline combat victories. Instead, it served a vital existential purpose for the Design Bureau. The Ka-18 successfully demonstrated that Kamov's specialized coaxial technology was completely production viable for civil applications. This civil success established crucial manufacturing credibility that directly supported the Bureau's subsequent, highly sensitive military helicopter programs. Fundamentally, the Hog kept the Kamov Bureau's assembly lines moving and its elite technical staff operational between major state military contracts. Without the quiet success of this small utility machine, the terrifying coaxial naval and attack helicopters of the modern era might never have left the drawing board. It remains a masterclass in strategic industrial preservation. The dawn of the turbine age sparked a massive re-evaluation of Soviet military-industrial strategy. On September 22, 1961, a sleek new light helicopter took to the sky. The Mi-2, codenamed Hoplite by Western forces. But what makes the Hoplite truly legendary is not just its design, but an extraordinary, unprecedented political decision. When full production commenced in 1965, the Kremlin decided to completely outsource the manufacturing of this entire light utility category to a Warsaw Pact ally, assigning the exclusive production rights to the PZL Swidnik factory located in Poland. This outsourcing maneuver was highly irregular, breaking with strict, paranoid Soviet industrial policies that fiercely mandated keeping sensitive defense manufacturing inside Soviet borders. Despite this break from tradition, the gamble paid off spectacularly. Through 1992, an astonishing 5,497 Mi-2 helicopters rolled off the Polish assembly lines. This nimble twin-turbine aircraft went on to serve with 25 nations across the globe. Thanks to its remarkable durability, ease of maintenance and rugged reliability, the Hoplite outlived the very empire that commissioned it, and it remains operational with several air forces around the world today. It stands as a testament to international cooperation in an era defined by deep suspicion. In the vast, unforgiving expanse of the Soviet wilderness, conventional transport methods often failed completely. The military needed a radical tool to conquer logistics. Enter the Mi-10, known to NATO as the Hawk, first taking flight on June 15, 1960, and entering active service in 1963, this bizarre, towering mechanical spider solved a highly specific logistics dilemma that no other aircraft type could address. How do you transport immense, rigid military hardware that is simply too massive or delicate to be carried by a standard underslung cable? The Mill Bureau's brilliant solution was a massive four-legged undercarriage system, providing a towering 3.75 meters of ground clearance, allowing the helicopter to literally straddle its cargo. A total of 55 standard models and 17 specialized Mi-10K flying crane variants were manufactured. In military applications, the Hawk proved indispensable, effortlessly lifting and transporting entire Scud ballistic missile transport, erector launchers, massive oil pipeline sections, and heavy tactical bridge elements across treacherous terrain where traditional wheeled cranes could not operate. The Mi-10 redefined the concept of heavy logistics, turning impossible engineering challenges into routine transport assignments. It remains one of the most uniquely specialized heavy lifters to ever patrol the skies. Deep within the Cold War arms race, the Soviet Union faced a monumental strategic nightmare: how to secretly transport massive intercontinental ballistic missile components across the vast, roadless tundra of Siberia. The answer was a mechanical titan of mythic proportions. The Mi-12, also designated as the V-12 and codenamed Homer by NATO, was the ultimate super-heavy helicopter. First taking flight on July 10, 1968, this twin-rotor behemoth shocked the world on August 6, 1969, by lifting an absolute earth-shattering payload record of 44,205 kilograms to an altitude of 2,255 meters. To this day, that staggering record remains completely unbroken by any helicopter in aviation history. Only 2 prototypes of this giant were ever constructed. Ultimately, the high-stakes program was cancelled because Soviet strategic missile doctrine transitioned to different deployment concepts, rendering the giant aircraft redundant. 55 years have passed since the Homer first asserted its dominance, and no other helicopter has even come close to matching its colossal payload record. It stands forever as a breathtaking, unmatched peak of Soviet aviation ambition, a monument to a time when designers built without limits. It remains an unforgettable symbol of engineering prowess, towering over history. In the highly competitive arena of high-speed vertical flight, the Kamov Bureau took a monumental, daring gamble. They envisioned a radical hybrid that would fuse the vertical capability of a helicopter with the blazing forward speed of a conventional cargo plane. The result of this ambitious engineering dream was the Kamov Ka-22, codenamed Hoop. First taking flight on August 17, 1959, this massive compound rotorcraft stunned global aviation observers by setting an incredible world speed record of 356 kilometers per hour on October 7, 1961. Remarkably, that record still stands today for its unique convertiplane category. But pioneering such cutting-edge technology carried a heavy, tragic price. The entire program was abruptly cancelled after 2 horrific, fatal crashes during development testing. These catastrophic accidents exposed deeply systemic, unresolvable aerodynamic stability problems, specifically during the perilous transition phase between vertical hover and high-speed forward flight modes. While the core concept of a high-speed compound helicopter remained highly relevant to military strategists, the specific implementation proved ultimately unresolvable for Kamov's team. The Hoop remains a fascinating, tragic reminder of the dangerous razor's edge walked by Soviet aviation pioneers. Their sacrifices paved the way for future generations of tilt-rotor technology worldwide. To secure the oceans, the Soviet Navy faced a critical tactical bottleneck. Standard helicopters were simply too large to operate from the cramped decks of surface combatants. The solution came from the seafaring specialists at Kamov. First flying on April 26, 1961 and entering active naval service in 1966, the Kamov Ka-25, codenamed Hormone, became the very first purpose-designed Soviet naval helicopter. A total of 460 airframes were built, primarily split between the Hormone A anti-submarine variant and the Hormone B targeting platform. The iconic coaxial rotor configuration was not an aesthetic choice, but a practical requirement imposed by the ships it served. By completely eliminating the tail boom, the Ka-25 could safely land and fit into tight shipboard hangar spaces that a conventional helicopter of equivalent payload could never occupy. Furthermore, the Hormone B over-the-horizon targeting variant completely revolutionized naval warfare. It provided critical targeting data for the devastating P-500 Basalt anti-ship missiles carried by Moskva-class cruisers, giving those ships an immense engagement range that vastly exceeded their own radar horizon. The Hormone had officially conquered the high seas, cementing Kamov's absolute dominance in naval aviation architecture forever. It is the undisputed king of the skies, a mechanical legend whose sheer numbers defy imagination. The Mi-8 and its advanced derivative, the Mi-17, codenamed HIP, first flew on June 24, 1961, and entered service in 1965. With over 17,000 airframes produced across 40 distinct variants for more than 100 nations, it stands as the most produced military helicopter in history. When the harsh, thin air of Afghanistan exposed performance limitations, the MIL Bureau engineered the Mi-17 in 1975, retrofitting the airframe with twin TV-3117 turbines, producing 1,900 shaft horsepower each to dramatically improve hot and high operational capabilities that altitudes had exposed as a limitation. The HIP's staggering combat record spans virtually every major armed conflict across the globe. No other aircraft type in existence has operated in more distinct conflicts under more national flags in the same 60-year period. From the deserts of Africa to the frozen peaks of Europe, its iconic silhouette remains synonymous with battlefield mobility. Decades after its introduction, this indomitable aviation icon remains in active production, proving that true mechanical genius never goes out of style. It is the global backbone of rotary aviation. To defend its massive maritime borders from Western submarines, the Soviet Union needed more than just shipborne helicopters. They required a long-range, shore-based patrol asset. The MIL Bureau delivered by taking their most reliable platform and modifying it for the open ocean. The result was the Mi-14, codenamed Haze. First flying on August 1, 1967 and entering Soviet naval aviation service in 1976, approximately 230 units were constructed across specialized anti-submarine warfare, minesweeping, and search and rescue variants. To master the aquatic environment, engineers took the proven Mi-8 airframe and completely adapted it for naval operations through the addition of a heavily sealed amphibious boat hull and sponsons that allowed the aircraft to safely perform direct water landings. Boasting a substantial operational radius of approximately 200 kilometers from base, combined with the unique capability to land on the ocean surface for extended loiter times, the Haze provided Soviet naval aviation with a powerful patrolling capability. This distinct range envelope perfectly complemented ship-based Kamov Ka-25s, forming a dual-layered defensive shield that Western submarine captains feared to cross during the height of the Cold War. The Haze effectively blurred the line between aviation and seafaring power. It is the ultimate symbol of Soviet military might, a terrifying, heavily armored leviathan known simply as the Crocodile by its crews and the Hind by NATO. First flying on September 19, 1969, and entering Soviet Army aviation service in 1972, the Mi-24 family would see 2,500 units built across 8 major variants for 50 nations. This predatory machine shattered records, setting a world helicopter speed record of 368.4 kilometers per hour in 1978. The Hind was boldly conceived as a flying infantry fighting vehicle, a heavily armed attack gunship that could simultaneously deliver gunfire, launch anti-tank guided missiles, and carry 8 fully armed combat troops directly to the objective. However, the brutal crucible of Afghanistan provided definitive operational data. While incredibly effective in open terrain, the Hind proved highly vulnerable to shoulder-fired man-portable missiles inside confined mountain valleys, where its blistering speed could not be leveraged. The Mi-24 definitively defined the modern attack helicopter for a generation of military planners, but the unforgiving battlefields of Afghanistan ruthlessly defined the strict limits of that rotary dominance. It remains an enduring legend of airborne firepower, echoing through military history. As the Soviet Navy expanded into a true blue-water global force, it required a highly sophisticated, multi-role rotary family to protect its fleets from multi-domain threats. The apex of this evolution arrived with the Kamov Ka-27 lineage, codenamed Helix by Western forces. Representing the mature, definitive expression of Soviet naval helicopter design, this family introduced the Ka-27PL anti-submarine variant into service in 1982, followed closely by the Ka-28 export model and the rugged Ka-29 assault transport variant. But the true technological crown jewel of this family was the highly specialized Ka-31 airborne early warning helicopter, which officially entered service in 1995. The Ka-31 mounted the massive deployable E-801 OCO radar system beneath its fuselage, providing an unprecedented 150-kilometer surveillance radius against incoming air targets. This marked the very first time in history that a shipborne helicopter had successfully carried a deeply meaningful, long-range airborne early warning capability. By packing such immense radar power into a compact airframe without a tailboom, Kamov provided Soviet carrier groups with an organic eye in the sky, shielding the fleet from low-altitude anti-ship missile attacks. It remains a masterful synthesis of naval utility and sensor technology. Prepare to meet the undisputed Leviathan of the skies, a machine so jaw-droppingly massive it challenges the laws of aerodynamics. The Mi-26, codenamed Halo by NATO, first took flight on December 14, 1977, and entered Soviet service in 1983. With over 340 airframes built and production incredibly continuing to this day, it reigns supreme as the largest helicopter to ever enter serial production. The Halo's lifting capabilities are the stuff of aviation legend. Its cavernous cargo hold can literally swallow a T-80 main battle tank whole. Its supreme dominance was dramatically demonstrated to the world in 2002 when an Mi-26 successfully recovered 2 downed American CH-47 Chinook helicopters from the treacherous mountains of Afghanistan. The American aircraft was simply too large and heavy for their own kind to recover, requiring the brute force of the larger Soviet machine. After more than 40 years of continuous service, the Mi-26 has no equals. Its ongoing production reflects a stark global reality. There is an absolute absence of any competing design anywhere in the world capable of executing its primary heavy lift mission, cementing its status as an eternal king of vertical lift. As the Cold War reached its final chapter, the Mil Bureau set out to build the ultimate uncompromising dealer of battlefield destruction. First taking flight on November 10, 1982, the Mi-28, known to NATO as the Havoc, faced an incredibly grueling path to the front lines. Its 14-year development cycle was abruptly interrupted by the cataclysmic collapse of the Soviet Union, delaying initial production until 1996. The heavily upgraded Mi-28N Night Hunter variant finally entered frontline service in 2008. Unlike its predecessor, the Mi-24, the Havoc was a pure, dedicated attack helicopter, completely unburdened by the tactical compromise of carrying troops. It was engineered for one singular purpose: hunting armor. However, the brutal conflict in Ukraine starting in 2022 has drastically exposed the vulnerabilities of traditional gunships in modern high-intensity warfare. Operating in highly lethal airspace, Mi-28N losses to shoulder-fired man-portable air defense missiles and agile low-cost FPV drones have been significant. These losses have been starkly and publicly documented through relentless Ukrainian battlefield footage. The Night Hunter now faces its greatest challenge, adapting to a chaotic era where cheap drone tech hunts the apex predators of the sky. In the high-stakes theater of modern aerial combat, the Kamov Bureau unleashed their most radical, technologically audacious designs yet: the single-seat Kar-50 Hokum and its lethal two-seat evolution, the Kar-52 Alligator. First flying on June 27, 1982, and entering service in limited numbers in 1995, the Hokum broke every rule of conventional design. The mature Kar-52 Alligator entered frontline service in 2011. Both cutting-edge war machines incorporated Kamov's legendary trademark coaxial counter-rotating rotor system and a revolutionary world-first feature for helicopters: the K-37-800 rocket-propelled ejection seat. Yet, the brutal war in Ukraine since 2022 has shattered expectations, as the Alligator has suffered the highest documented loss rate of any Russian military helicopter. Kamov's doctrine intended for the Kar-52 to leverage the long-range Hermes missile, striking targets from 15 to 20 kilometers away while remaining completely safely beyond Manpad's engagement zones. However, executing this standoff tactic has HTML proven incredibly difficult in the fluid, rapidly shifting tactical environment of the modern battlefield. The Alligator stands locked in a desperate struggle for survival, proving that even the most high-tech weapon systems must constantly adapt. In 1945, Joseph Stalin issued a high-stakes command: copy the American B-29 Superfortress. 3 US bombers had made emergency landings in the Soviet Far East, handing Moscow an unexpected blueprint for advanced aviation. By 1947, the dedicated intelligence variant, the Tupolev Tu-4R, entered service, establishing the Soviet Union's very first strategic aerial reconnaissance capability at the precise moment the Cold War was defining its global parameters. This piston-engine giant stripped away defensive armament to fit advanced AFA-33 and AFA-75 cameras inside its modified bomb bays and fuselage. It flew at a ceiling of 11,200 meters with a 5,400-kilometer range, mapping 60-kilometer wide swaths of terrain in a single pass. Operating from Siberian and European bases, it gathered photographic proof of NATO installations across Germany, Italy, Turkey, and the Pacific Rim. But its supremacy was short-lived. In 1949, the arrival of NATO's jet-powered F-86 Sabre interceptors instantly transformed this piston-driven aircraft into an incredibly vulnerable target. It could neither outrun nor outclimb nimble enemy jet fighters. Its operational lifespan lasted a mere 5 years before routine flights became prohibitively risky, forcing Soviet designers into a frantic race to build survivable jet platforms. While strategic bombers mapped continents from high altitude, Soviet ground forces required a different kind of vision: low-altitude, tactical intelligence. Enter the Ilyushin Il-14R. Entering service around 1953, this specialized tactical reconnaissance variant was adapted from the dependable IL-14 twin-piston transport, equipped with vertical and oblique camera installations like the A-FA, B, A-40 and N-AFA Mk-75, and carrying early passive electronic intelligence receivers, it served a vital dual function for the Soviet VS and GRU. It captured high-resolution details for target assessments that high-flying strategic bombers simply missed. However, with a modest ceiling of 7,400 meters and a cruise speed of just 417 kilometers per hour, the Il-14R was highly vulnerable. It was confined to areas where Soviet air superiority was absolute, or along maritime borders just inside friendly airspace. Widely exported, Warsaw-packed nations like East Germany, Poland, and Czechoslovakia relied heavily on the Il-14R for battlefield planning. Despite its success in collecting vital electronic and photographic intelligence, its 3,200-kilometer range was strictly limited. It could not provide deep strategic penetration against American targets, leaving that dangerous task to the massive jet-powered platforms waiting in the wings. As the late 1950s arrived, the Cold War demanded unprecedented speed and altitude. The Soviet answer for tactical jet reconnaissance was the Yakovlev Yak-27R, known to NATO as Mangrove. Entering service in 1958, this twin-jet aircraft gave frontal aviation an asset capable of near-supersonic speeds. Driven by dual RD-9AK turbojets, the Mangrove hit Mach 0.97, while its impressive 16,500-meter ceiling pushed it safely above early NATO surface-to-air missiles and interceptors. Its extended nose housed advanced AFA-40 forward-facing cameras for high-resolution path coverage, paired with oblique fuselage cameras to capture targets offset from its flight track. Soviet doctrine mandated strict, pre-planned camera runs, delivering highly standardized, reproducible intelligence for photo interpreters. Around 180 units were built, but the Yak-27R's frontline reign was remarkably brief, lasting only until the mid-1960s. The blistering pace of Cold War aviation technology rapidly made it obsolescent, forcing a transition to the superior Yak-28R. Yet, the Mangrove left an enduring legacy, firmly establishing the Yakovlev Design Bureau as Russia's premier developer of tactical reconnaissance assets during the critical early years of NATO's military build-up, proving that Soviet aviation could effectively match Western capabilities in the high-stakes game of global aerial espionage. In 1955, the Soviet Union introduced a twin-jet Titan that would stalk NATO forces for 3 decades. The Tupolev Tu-16 family, known to the West as the Badger. Deployed across 3 highly specialized sub-variants, this platform established a continuous pattern of peripheral collection. The Tu-16R photo variant utilized advanced AFA 42 cameras in modified bomb bays. The Tu-16RM ELINT variant focused strictly on passive electronic intelligence to map out NATO radar networks. Meanwhile, the high-stakes Tu-16RR nuclear air sampling variant flew directly through radioactive clouds to capture debris from Western weapon tests. Powered by dual RD-3M 500 engines, these jets maintained a 5,800-kilometer range, keeping a constant, menacing presence over the Mediterranean from Egyptian and Syrian bases. They shadowed American Sixth Fleet maneuvers, gathering electronic signatures that Soviet submarine planners used to exploit gaps in Western anti-submarine tactics. The Tu-16RR missions were invaluable, providing raw physical data from American and French blasts that allowed Soviet physicists to reverse engineer Western weapon designs. Flying until the 1963 Partial Test Ban Treaty ended atmospheric tests, the Badger solidified its place as an irreplaceable, long-serving cornerstone of Soviet strategic intelligence throughout the tensest decades of the early Cold War. When the American U-2 began flying unchallenged over Soviet territory, Moscow demanded an immediate response. The result was the Yakovlev Yak-25 RV, codenamed Mandrake. First flying in 1959, this high-altitude strategic reconnaissance aircraft was adapted from an interceptor airframe. Designers added a massive 23.4-meter high aspect ratio wing to achieve the extreme lift required for a 20,000-meter operating ceiling. Though it accepted speed compromises, it created a rapid counterintelligence solution. Its absolute ceiling of 21,300 meters initially kept it above Western threats, but upgrades to Western-facing systems and Soviet SA-2 missiles proved high altitude was no longer an absolute shield. Following the bitter 1960s Sino-Soviet split, Mandrakes flew critical, perilous overflights directly above China's highly secretive nuclear test site at Lop Nur, providing vital intelligence at a moment when Beijing represented a genuine threat to Soviet security. Simultaneously, the Yak-25 RRV variant swapped out long focal-length cameras for atmospheric sampling gear to collect post-test nuclear fallout. Serving loyally through the mid-1970s, the Mandrake established the core operational methodology of Soviet high-altitude collection. It held the line until the unstoppable Mach 3 MiG-25R arrived to permanently rewrite the rules of strategic reconnaissance airspace. In 1963, Soviet frontal aviation unlocked a devastating new capability: supersonic tactical reconnaissance. The vehicle was the Yakovlev Yak-28R, NATO reporting name Brewer-D. Derived from a light bomber, this twin-jet platform blazed through defended airspace at a blistering Mach 1.73, backed by a 16,000-meter ceiling. What made the Brewer-D a true game-changer was its highly innovative, interchangeable internal sensor bay. Mission planners could instantly swap between 4 distinct configurations. Options included day vertical photography, oblique border surveillance, night photography using flash bombs, or a cutting-edge infrared system. This advanced thermal capability allowed pilots to expose hidden underground bunkers, heated hangars, and fuel storage facilities by detecting heat signatures entirely invisible to standard optical cameras. Built in a run of roughly 183 aircraft, the Yak-28R dominated tactical intelligence operations throughout the 1960s and 1970s. It even saw action during the early, brutal years of the conflict in Afghanistan before more survivable options arrived to reduce its operational tempo. The Brewer D eventually gave way to newer aircraft, but its innovative standardized sensor bay design forever altered how the Soviet military approached multi-role battlefield intelligence. Entering service in 1962, the Tupolev Tu-22R family, known to NATO as Blinder C, brought terrifying supersonic speed to Soviet long-range aviation. Rocketing through the skies at Mach 1.42 with massive VD-7M turbojets, this striking aircraft operated at an impressive 14,700-meter ceiling, outrunning contemporary Western interceptors. 4 distinct sub-variants were developed to map the global landscape. The standard Tu-22R and extended range RD utilized advanced AFA 54 cameras optimized for medium-altitude, oblique photography, sweeping massive areas of terrain to continuously update Soviet military databases. Meanwhile, the RK and RKD variants packed the potent Cub-3M passive collection system, designed to stalk international airspace and harvest radar signatures from NATO naval vessels. The Blinder C proved its operational worth in unforgiving global hotspots. It flew dangerous reconnaissance missions during the 1977 Ogaden War in Somalia and later monitored the US 6th Fleet during the volatile 1986 Libyan crisis. Libya also deployed these supersonic platforms during conflicts in Chad, serving until the collapse of the Soviet Union in the early 1990s. The Tu-22R family provided an aggressive, high-speed eye in the sky that challenged Western naval and ground dominance across the Mediterranean, Atlantic, and Pacific. In 1969, the Soviet Union unleashed the ultimate speed demon of the Cold War, the MiG-25R reconnaissance family, codenamed Foxbat. Built for a singular, brutal purpose, the Foxbat was engineered to fly at speeds and altitudes that rendered Western air defenses completely useless. Cruising at Mach 2.83 with a terrifying dash speed of Mach 3.2 at 23,000 meters, it was completely untouchable. In 1971, Soviet-piloted MiG-25Rs overflew Israeli-controlled Sinai. Desperate Israeli Air Force F-4 Phantoms scrambled to intercept, launching 8 AIM-7 Sparrow missiles. The missiles failed to reach the Foxbat's extreme altitude, detonating harmlessly below while the Soviet jet calmly completed its camera run. Spanning 6 sophisticated sub-variants across global operators like Egypt, Syria, Libya, and India, the Foxbat combined intelligence with strike capabilities. The RB variant carried heavy bomb loads alongside its cameras, while the RBK and RBF versions packed elite Smerch passive ELINT suites. India's fleet conducted vital reconnaissance over Pakistan during the 1971 war. From monitoring China and NATO borders to flying intense missions over Afghanistan, the iconic MiG-25R proved that in the deadly arena of aerial espionage, sheer speed was the ultimate weapon. In the vast, lonely expanses of the world's oceans, a high-stakes game of cat and mouse defined the Cold War. At the center of it was the Tupolev Tu-95RT, known to NATO as the Bear D. Entering Soviet naval aviation service in 1962, this massive 4-engine turboprop giant performed the fleet's most operationally critical function, hunting American aircraft carrier battle groups in real time. Equipped with a powerful Uzbek-1, A surface search radar housed in a massive belly radome, the Bear D boasted an incredible 12,500-kilometer range and an 18-hour endurance. It tracked US carriers from 400 kilometers away, transmitting precise position, course, and speed targeting data directly to Soviet anti-ship missile submarines lurking over the horizon. To counter this threat, American carriers constantly scrambled F-14 Tomcats to intercept and shadow the lumbering giants. This sparked hundreds of intense non-combat aerial confrontations over the North Atlantic, with Western aviators photographing the massive Soviet aircraft at dangerously close range. Operating as a global sentinel until the sudden collapse of the Soviet Union, its vital function later absorbed by satellites, the Bear D was a chilling reminder that no target on the open ocean could ever truly hide from the Kremlin's watchful eye. Hiding in plain sight, the Ilyushin Il-2 family, NATO codename Coot-A, transformed a standard turboprop airliner into the Soviet Union's premier signals intelligence vacuum. Hitting the skies in 1968, the Il-20M stripped away civilian comforts to house a massive Igla, one-side-looking airborne radar in a prominent ventral canoe, fairing alongside advanced Rhomb-4 ELINT and Kvadrat-2 communications intercept systems. This formidable combination allowed a single aircraft to simultaneously collect radar imagery and intercept communications along tense NATO borders and Chinese frontier regions. The Igla-1 radar penetrated thick cloud cover and total darkness, mapping ground terrain up to 50 kilometers away. But decades later, this Cold War veteran met a tragic end. On September 17, 2018, an Il-20M operating over the Mediterranean during the Syrian conflict was accidentally shot down by a Syrian S-200 missile. All 15 Russian crew members perished when frantic Syrian air defenses misidentified the massive aircraft, which was being used as radar cover by attacking Israeli F-16. Russia fiercely blamed Israel, while Israel blamed Syrian operator error, but the Cold War-era giant was permanently lost. It was a devastating catastrophe, proving that even the most sophisticated electronic platforms remain vulnerable in the chaotic fog of modern proxy warfare. In the high-altitude skies of the Cold War, the Antonov An-12 BKIS and An-12 PP, known to NATO as Cub-C and Cub-D, conducted a daring mission that effectively blurred the lines between reconnaissance and active electronic warfare. Entering service around 1965, these modified military transports were designed to aggressively disrupt the enemy. Armed with the Fasol passive ELINT collection system and the potent cargo bay-housed SPS-100 Reseda active jamming suite, these aircraft broadcast powerful noise, jamming directly across NATO air defense radar frequencies during international flights. It was a bold display of coercive diplomacy, collecting vital intelligence while proving they could blind Western defenses simultaneously. Throughout the 1970s and 1980s, the Cub became a constant shadow over massive NATO exercises like Reforger and Able Archer. Circling just outside restricted airspace, they collected critical data on Western response times, force deployment patterns, and communications protocols. This invaluable operational intelligence provided Soviet war planners with the exact blueprints needed to execute a highly coordinated attack. The An-12 proved that sometimes the most effective way to spy on your enemy is to completely jam their radar and watch exactly how they scramble. It was electronic warfare hiding in a transport shadow. By 1983, the Soviet Union introduced a swing-wing marvel that revolutionized battlefield intelligence, the Sukhoi Su-24MR, codenamed Fencer-E. Operating as frontal aviation's premier tactical reconnaissance asset, this twin-engine jet achieved a top speed of Mach 1.35 and a ceiling of 17,500 meters. But its true lethality lay in its groundbreaking BKR-1 multi-sensor suite. For the first time, a single tactical aircraft could simultaneously gather radar, optical and infrared data using the Shtik-2M side-looking airborne radar, the AIST-M panoramic camera and the Zima infrared line scanner. Earlier, reconnaissance platforms relied on single sensors that could be fooled by camouflage or decoys, but the Fencer-E forced adversaries to defeat three distinct intelligence domains at once. Its variable sweep wings provided unmatched aerodynamic flexibility, shifting from low-altitude, high-speed dashes that denied defenders any reaction time to efficient, medium-altitude mapping cruises. With roughly 100 units produced, the Su-24MR proved indispensable during brutal combat operations in Chechnya, mapping out entrenched enemy positions across Grozny. The Fencer-E completely redefined tactical espionage, remaining a vital Russian Air Force asset through the early 2000s until modern satellites and unmanned drones finally began to inherit its dangerous frontline crown. In 1983, Soviet long-range aviation introduced a terrifying supersonic phantom that triggered immense international controversy, the Tupolev Tu-22M-3R, known to NATO as the backfire Tsarist. This heavy-hitting, swing-wing platform was stripped of its traditional weapons load to carry the state-of-the-art UKR-1 Chompol reconnaissance system in a centerline container. Surpassing the older Tu-22R in every single performance dimension, it blazed through the stratosphere at Mach 1.88 with a massive 6,800-kilometer unrefueled range, combining wide-area panoramic photography with side-oblique cameras that peered up to 100 kilometers away. This allowed a single flight to map entire military districts, while onboard passive ELINT receivers simultaneously harvested radar signatures. But the backfire C's most intense battles were fought at the negotiating tables of the SALT and START arms control treaties. The Kremlin deliberately classified the airframe as a medium bomber to bypass strict deployment limits, a calculated move that American negotiators hotly contested but ultimately accepted. Whether this highly advanced reconnaissance variant violated international treaties remained a fierce debate among intelligence analysts. The Tu-22M-3R existed in a state of deliberate strategic ambiguity, a ghost in the treaty books and an unstoppable eye in the sky. When the Kremlin required global range, it turned to an enduring icon of Soviet air power, the Tupolev Tu-95MR, known to NATO as Bear-E. Entering service in 1966, this strategic behemoth extended the reach of Soviet intelligence to the absolute ends of the Earth. Utilizing the legendary turboprop endurance of the Bear airframe, the Tu-95MR could map the Pacific from Kamchatka to the mid-Indian Ocean without refueling, or complete a full North Atlantic circuit with a single aerial top-off. Housed inside its massive, modified bomb bay was a specialized array of 7 advanced AFA cameras, providing comprehensive vertical and oblique photographic coverage. In an era when early spy satellites left massive, predictable gaps between orbits, the Bear-E filled the void with responsive, human-crewed surveillance. It systematically documented American and Allied bases across the Pacific Rim, Indian Ocean, and Atlantic, creating an invaluable database of Western deployments. Ironically, the Bear E became an intelligence subject itself. Western signals intelligence heavily monitored its communications and navigation systems throughout each flight, building a database of Soviet operational patterns. It was a high-stakes chess match, played out at 12,000 meters. Each exhausting mission became a complex, two-way mirror of global espionage, solidifying the Bear E as an irreplaceable sentinel of the Cold War. Taming a Mach-3 monster required an entirely unique class of aircraft. Enter the MiG-25 RU, NATO reporting name Foxbat C. Entering service in 1972, this striking two-seat reconnaissance trainer featured a dramatically raised second cockpit for an instructor, positioned directly behind and above the student pilot's forward station. Its primary, high-stakes mission prepared Soviet aviators for the unforgiving extreme flight envelopes of high-speed, high-altitude intelligence collection. Because handling the massive Foxbat at Mach 2+ and extreme altitude was unlike anything pilots had ever experienced, specialized training in energy management and emergency protocols was absolutely mandatory. The second cockpit reduced internal fuel volume, limiting its range compared to single-seat variants, but with a maximum speed of Mach 2.83, its performance remained absolutely blistering. This unmatched speed unlocked a legendary secondary role. The Foxbat C became the Kremlin's ultimate high-speed courier and VIP transport. It rushed critical intelligence products, film canisters, and senior officials between strategic locations faster than any other aircraft in the Soviet inventory. In an era before satellite data links made physical film transport obsolete, the MiG-25 RU proved that when an asset is too fast to be intercepted, it is also far too fast to be delayed. Born from one of the most bizarre chapters of Cold War espionage, the Mi-24 M17 Stratosphera and its successor, the M55 Geophysica, known to NATO as Mystic, trace their origins to a battle against silent invaders. In 1956, the CIA launched Project Genetrix, drifting hundreds of high-altitude spy balloons across Soviet airspace. Frustrated by an inability to intercept these slow-moving targets, the Kremlin demanded a radical solution. First flying in 1982, the M17 was purpose-built to destroy them. It featured an astonishing aspect ratio wing spanning 40.32 meters, wider than a Boeing 727, providing extreme maneuverability at a stratospheric 20,000-meter ceiling. When the balloon threat subsided, this unique design evolved into the twin-engine M55 in 1988, shifting focus to high-altitude strategic reconnaissance and atmospheric sampling. Incredible as it seems, the M55 Geophysica remains operational in 2024, performing critical atmospheric research and specialized intelligence missions. Still flying high-altitude research sorties more than 42 years after the first prototype initially lifted off, it commands a region of the sky few other aircraft can ever hope to reach. This legendary platform has outlasted the CIA balloon program, the Soviet Union, and the Cold War itself, proving that brilliant aeronautical engineering can transform a specialized weapon into an enduring scientific marvel. To dominate the world's oceans, the Soviet Navy required an aircraft that could simultaneously hunt Western submarines and harvest electronic secrets. Their answer was the Ilyushin Il-2, codenamed May. Entering service in 1967 and derived from the Il-18 airliner, this long-endurance Titan maintained a grueling 12-hour patrol capability. Deployed to strategic global hotspots like Egypt, Libya, Yemen, Ethiopia, India, and Somalia during the height of the Cold War, the ME combined advanced anti-submarine warfare with elite electronic intelligence collection. Utilizing its powerful Bakut surface search and navigation radar with a 300-kilometer range alongside specialized sonobuoy fields and passive ELINT receivers, it meticulously mapped out the electronic order of battle for Western naval fleets. Decades later, the plane found a vital afterlife with a foreign power. India acquired the heavily upgraded IL-38N variant, packing the state-of-the-art Novella P-38 multimode sensor suite that dramatically boosted both ASW and SIGINT capabilities. During intense geopolitical tensions, Indian crews deployed these modernized platforms to monitor Pakistani movements and track Chinese naval activity across the Indian Ocean. In a brilliant twist of historical irony, the Cold War intelligence platform that the Soviet Union originally built to track American submarines was now operated by India to track Chinese ones, acquiring a powerful new role in a completely different great power competition.